Alright, today with Unit 1 we doing exercise 9H, which is a similarity factor. What you need to remember with the similarity factor, it's the ratio of the sides between two shapes, one image over the original shape. So one way they express it, so you have two shapes here, they will be said to be similar. The K factor, so you start with a length AB from the original image for the original shape, I should say, and then you have the image shape. Then we annotate A prime, B prime. The dash tells you it's the similar shape. Then the length will be the original length times K. So that's equal to A prime, B prime. And usually to find the K value, we do the ratio of AB of the image over the AB of the original. Okay? We can extrapolate that to determine the area and the volume of the original or the image, depending on what you know. Okay, again, the application of that is you will have those new geometrical concepts, but the problems may ask you to solve some features of the original or the image, the length, area, or volume. The area, think about it as a square. So the basic shape in terms of area unit is a square, so it's the side by the side. When you do that for the image, the side of the image is K. If you multiply it by itself, you're gonna end up with a K squared factor. That is why you have that K squared. For a volume, for a unit volume, it's a cube. So the volume of that cube is the three sides times together. So if the side of the cube is KAB, you multiply or you raise it to the power 3, you're going to have a K cube factor that you can factorize. Okay? So keeping that in mind, that you have that K squared, K cube respectively for the length, the area and the volume between the original and the image. Now it doesn't matter if the image is smaller, it's whatever matters you start with. So if you start with a let's say you have a you enlarge, you start from a smaller original to a larger, you enlarge to a similar shape, what happens is your K factor is going to be greater than 1. But then if you reduce it, if you have a larger and you go down to a smaller one, then the K factor is going to be between always positive, so it's greater than 0, and it's going to be less than 1. So let's say you reduce by 2, the K factor will be a half. Okay, so just keep that in mind as well. It's a real positive number. If it's between 0 and 1, it's a reduction. If it's greater than 1, it's a magnification or enlargement. Okay. So first example with area calculation. So you have two shapes. So let's say we label it. Let me get my magic tablet. I have a small desk, so I'm gonna have to juggle between the mouse and my pen. So let me say this one is, I don't know why it's not working. Let me unplug, replug. Okay, so that's my original, that's my image. Okay, the task is to find the area of the image rectangle. First thing is you need to find your K factor. Okay, I'm going to do the working out. It's probably obvious you already have the value, but it's going to be the ratio of A prime, B prime, and the reason I chose those sides is because I know their measurements, and that gives me 5/3. Okay, again greater than 1, so it's a magnification. You can see the image is larger than the original. Now you know the area of the original rectangle, so to find the area of that rectangle, it's going to be equal to k squared times the area of A, B, C, D, if I use the same notation. Okay, and then you can find the you just evaluate that. So that's going to be, you use your CAS, you do 5/3, you square it, you multiply by 20, and you get the area. Don't forget, it's the same units, so it's going to be in square centimeters. Thanks, Angelo. Yes, John, you're late, but it's an online session, it doesn't really matter. Alright, so we have that for the ratio applied to areas. Next one is about volume. Okay, so it's very important you look at the shapes, you look at what the value that you know. So notice here on your shape, that's your original. So that's my original, that's my image. So from the original to the image, why is it doing this? So from the original to the image, you can find your K factor. Did it die again? I think my tablet died again. Okay, let me use my mouse then. So K is the side of the image over the side of the original. So you look at that side. By the way, the question part A is obviously guiding you for this. So you need to find the ratio of the length. So you look at the bases, you have a 4 here for the original and a 5, so K is equal to 5/4, 1.25. Here is the height of the original. So to find the height of the image, what you would do is, now it's working again. So what am I doing? Control C? No. So here the height of the original will be K times 9. Okay, you evaluate that. Don't forget, again, the units are in centimeters, so that's going to be in centimeters. Okay, volume. Now it's the volume of that pyramid. It's 48. Don't forget again the units, so it's in cubic centimeters. So the volume of the image is going to be in the same units. Okay, so hopefully you've done your K factor correctly. Obviously, if it's wrong, you will get the wrong answer. But again, you get consequential marks anyway. It's just good practice, obviously, to get the correct answer. So for the volume, you look at the volume, you look at your original. All the dimensions are there. So it's a square pyramid. So the base is a square, so you can find the area of the base, which is a 4/4, which is a 16 square centimeters, and you have the height. So do remember, for the volume, I'm going to call it V, for a pyramid is 1/3 of the area of the base times the height. So that's going to be 1/3 times 16 square centimeters times 9, that's 16 times 3. Why am I doing this? It's already given in a question. It's 48 anyway. But just in case you didn't know the formula, so that's the same. We get the same answer, so put a cube here. To find the volume of the image, it's going to be K. You bring it to a cube, but because that's a volume, multiplied by 48, and you use your CAS, 5/4 power 3 times 48, and your answer will be in cubic centimeters. Okay? Alright, and that's it for year 11s.